So this right here, okay, we want to prove that if we integrate x to the n, if we find an antiderivative of x to the n, it's equal to x to the n plus 1 over n plus 1 plus some constants of what we call the constant of integration. Okay, so here's what we're going to do. We're going to say, well, this right here is some function such that when we differentiate okay, so when we differentiate, that's f prime of x, we get this inside guy here, we get x to the n. Okay, but now f of x is said to be equal to this guy. So f of x, the large f of x, is equal to x to the n plus 1 over n plus 1 plus some constant of integration. Now if we differentiate this, f prime of x is equal to d dx of x to the n plus 1 over n plus 1 plus some constant of integration. And this is equal to ddx of x to the n plus 1 over n plus 1 plus ddx of c. And so the derivative of this is n plus 1 times x to the n plus 1 minus 1 over n plus 1. And the derivative of a constant is 0. And so these guys go away. And I'm left with x to the n plus 1 minus 1, which is just x to the n. And so what I've shown here is that the derivative of this function is equal to the guy in the inside box, which is what we're the guy on the inside of the integral, okay, or underneath the integral symbol. So the antiderivative of this is equal to this, and we've just shown that right here. So what is this trying to get at? Well, it's saying, look, let's say you've got some integral. We want to find the antiderivative of, let's say, x to the third dx. So this part right here, this just says we want to find an antiderivative of this function right here. And so our rule says you add, to find the antiderivative, you add 1 to the power and then you divide it by this guy, the same power, so 3 plus 1. So that's equal to x to the 4th over 4. And then we add to it that constant of integration. So this is the antiderivative of this guy right here. So the antiderivative of this guy is equal to this. And if we differentiate, the derivative of x with respect to, so the integral, this is going to give me x to the third, and the derivative of this side is 4x to the third over 4 plus 0, which is equal to just x to the third. So we verify that if we want to integrate and we find the antiderivative, we just add 1 and divide by that guy. So the integral of x to the 6th dx is equal to x to the 7th over 7, just like that.